Hi, I'm Dr. Ron England, and I'm actually shooting this video from Daytona State. And I'm calling it Open Letter to Microsoft, but really what I'm talking about is new programming paradigms. However, some of these paradigms could really be useful to a lot of different programmers if they were supported at a fairly universal level. So let's talk a little bit about what I'm talking about here, about programming paradigms. First, I use .NET a lot, and I actually like .NET. I like Visual Studio, I like .NET, but one of the issues with .NET is most of the applications I write, especially if you're writing web applications, rely very heavily on the data tier of the application. What that really means is you need a database. And as soon as you throw in that database, now you're going to have the expertise in the database and being able to do table design and store procedures and working with SQL and then data objects. And you get real complex real fast. Not really a big deal. I know how all that stuff works. I teach it. You've got lots of lectures out there if you want to watch on lectures on how to do all this. But the downside of this is really it takes a lot of my time. I want to be a very productive programmer. And what I mean by productive programmer is that I can churn out programs that do what I want them to do very rapidly without having, and what I mean rapidly is the amount of time that I actually spend programming. And what I did notice is that I was spending a lot of time managing the data tier, going into SQL Server Management Studio or the different studios for the different databases that I was using, writing the scripts for the databases, managing them, putting in the foreign keys, all the linkages, writing stored procedures. Okay, not hard to do. Okay, does require a level of expertise. Sometimes people have that expertise, sometimes they don't. But more important was it was taking a lot of my time. The time that I spent working on the database and then trying to keep it in sync with my application, okay, well, that was time I wasn't spent writing my application. Now, Microsoft's come up with all sorts of different solutions to this, like they've added something like Link, but Link was like putting something like lipstick on the pig. You still got two things to manage. You've got the code in the database to manage, and you've got the code in your C# or your .NET application to manage, and that doesn't solve the problem. So really, what I was looking to say is that can I figure out a way to do this better and get rid of all that time that I was spent managing the data tier, especially for some of the smaller applications that I wrote. So having been and dating myself going back into the late 80s and early 90s, I was actually a Smalltalk programmer, and just recently I've been working in other databases like DynamoDB, which is doesn't have any real table structure. I was looking for something easier that could solve basically solve the needs that I have. So here's what I did. I actually came up with a solution, and the solution has worked, and I've been using it in a lot of different applications that I've written. So what I want to do is I want to have a class that has the ability to save and retrieve itself. Now this is more than just the ability to save and retrieve. It has to have rich retrieval features where it can retrieve by date or retrieve by name or retrieve by different meta properties. And then create an object repository, which is just a location where these objects can actually be stored. Now, in reality, my object repository is a database, but it's a database with a fixed structure, and the structure never changes. It doesn't matter what object I'm storing in it, the repository can handle the structure of the object. So I created this base class, and I call that base class XML property object, which kind of reveals a little bit about how the whole thing works. Essentially what I do is I am able to take the object itself, turn it into an XML-based, the properties, turn them into XML, and store those into a database with a number of meta properties, or basically in this case metadata. And then all I have to do is make all the classes that I want to use inherit from this class. So when I have a class that's inherited from my XML property object, I can just save it and it saves, and I can retrieve it and it retrieves. Well, that's great in theory, but you got to practically make these things work. So how does that happen? Well, first thing is in the design I came up with a number of meta properties, and if you were designing this you might have different meta properties than what I've come up with, and since I've actually done these meta properties I've come up with other useful ones. But if you looked at what and these are actually properties of the base class, which in this case is XML property object, and these meta properties are ID, class, name, description, created date, and owner. Now I actually do practically in mine have a few more meta properties, which gives me the ability to do more things, but if I had to strip it down to just the basics of what you would need in these meta properties, these are them. So essentially when I create a an object that, or create a class which inherits from XML property object, it inherits the properties of XML property object, and one of these is ID. Every class in my object, or every object in my object repository has a unique ID, which kind of gives you a little bit of the structure of how that thing works. It is a table, and it does use an identity to assign these IDs. It has a class, okay, that's in the repository. The repository knows the class of the object, but a class knows its own class, and so it only has to look through classes of the same type to find itself. A name, which is just a user-defined name that I gave, not the name of the class. In this case, it's actually the name of an instantiated object. A description, which is not a text description of the class, it's a text description of the object, the instantiated member of the class. Created date and owner. So this is just some basic design capability, but these meta properties are important because you can easily search on any of those meta properties and not have a performance hit. The reason a performance hit would be an issue is because, well, I do actually still store this stuff in a database. So what kind of methods would you put into a class like this? Well, here's a few of them. I didn't put, I have a much broader list of them, but let's look at what kind of basic properties you'd have of an XML property object, or of a class that can save itself. One is select. In this case, the select, I pass it the integer ID, and it's simple. It goes into the object repository, finds the object of that specific ID, and it retrieves it back and it instantiates that object. Okay, wow, that's easy. Also, let's say you do select by and you pass it the name. Well, because multiple objects can have the same name, but even if they're of the same class, this is a static method, and it retrieves a collection of these, whatever this object is. And then you can go through those objects and figure out which one you want. Simple one, insert. Okay, well, if you want to, and I actually insert first time there, you actually do want to be able to, first time you have that object instantiated and you want to save it, you can call insert, and it actually returns back the ID and sets the ID of the object so the object knows its own ID. And update. Okay, now notice I am kind of geeking out on this whole thing here, and if you're not a programmer, you're going to be just scratching your head. But anybody who's got any high level of programming capability is going to look at this and hopefully see, wow, this could be extremely useful, that I could actually have classes that can, or instantiated objects from a class that I can just call a method insert, and voila, it inserts itself into a repository to be retrieved later with the select. Also notice that I used the common names that are the SQL names, not save, retrieve, or anything like that. Because I use SQL all the time. But update, there's the last one there. All right, so I did this. I've built this whole thing, and I've actually got a series of lectures showing how the whole thing was built. But I created this structure, and then I built multiple projects on this structure. Now, I originally expected my programming productivity, which I do track, to increase by a factor of around 2. I mean, I spent about half the time on the database, and I spent about half the time on the actual programming. And it's sad that I did that, but that I spent that much time on the database. That's just the way it worked. But I didn't realize how much time I spent coordinating between the database and the classes within the .NET and the C# code that I was writing. I actually saw practical productivity factor increases of around 3, meaning that a program that I would have normally gone and scoped out, and I write a lot of programs for other people, that I would have scoped out would have taken me 100 hours. I was able to produce these programs in about 30 to 35 hours of work, which for a high-level programmer, okay, that's a fairly significant productivity increase. Allowed me to be able to really churn out good stuff fast. An example application of this is one of the ones I have here. You can look at Smata Online. It is an example, and it does use this paradigm, and it's a fairly full-fledged application, and it's freely available. So if you want to just see something that uses this, there you go. Now, there are challenges to this approach. Well, one is there's no formal structure within Microsoft to do this. I wrote everything myself. I am very proud of writing everything myself. I've looked at some of the code that large programming groups such as Google have done, and with a team of 5 programmers working for a factor of a year, I was able to do essentially the same thing as one of their applications by myself in my spare time, about 2 hours a day in a course of about 6 months, and give entirely the same productivity as they've got from their application. Got questions about which one? I just don't want to call anybody out on this one, but hey, you can be pretty proud of something you're able to do with the structure that you have here. However, there are issues. One is performance. if you're not, if I'm not searching on an individual meta property, or in this case, metadata that's there, then you have a performance hit because you have to parse through each of the individual XML objects, and those have to be instantiated into an object to do that. There are ways to get around that, and I may actually implement some of those that I've thought of. The other one is the concept of actually handling objects. And when you deal with a relational database, you have this ability to put in the relations. And if you're using a single object repository, you don't have that ability to do references. However, in the case of these classes, I simply use dictionaries and lists, which are specific objects within the .NET framework that are different types of collections, to store the IDs of referenced objects, and it works just as well. The only thing that I can't do with that is it makes it very difficult to actually search on the references and get to that. You know what? It's still pretty awesome that this capability. So my final conclusion is then that this has worked very well, and it wouldn't be bad to see some sort of framework pop up that supported this entire conceptual paradigm for programming. So there's a challenge for those programmers out there. I think there's a tremendous reward out there for anybody who's able to do that. I'd love to, I've built one for myself, and it is actually freely available out there, but it's kind of, it's not a true built to order. It's something that I built so that I could do things that I wanted to do. So talking about new programming paradigms, there you go. It's actually a new paradigm. It's really an old paradigm, just refreshed. But it's out there now. Thanks, and good programming.